I think we are back.
Yes, I think so. Are you able to
Yes.
Yes, awesome.
join?
Okay.
Okay.
All right, everyone. We apologize for that little bit of delay there. Okay, so we are talking about fat analysis, and fat analysis is important because it is, directly related to nutritional labeling, product quality, regulatory compliance, process control, right? So these are all really important things. And at the end of the day, within, the food industries, pet food, feed, to optimize your manufacturing process, that's what's going to be the biggest savings at the end of the day. And so we want to be able to achieve that this modern method to be able to do that. It needs to be accurate and defensible data, operational efficiency, speed, sustainability. Okay, so this is really what I want you guys to take away as we talk through this, to come back and say, okay, yeah, they did that. They presented something that is a optimized method that is meeting these needs for what I have pictured there is the AOEC food triangle, right? So it breaks up the different components in food from fat to protein to carbohydrates and the different percentages. And essentially, our food, feed, pet food is going to fall in this. And we're going to be able to run all of this. So we have a very optimized method for regardless of the sample that you're looking at. So our goal is to show you that method. So let's move. All right. So with that, we're going to talk a little bit about the history of fat testing to kind of bring us up to speed and where we're at today. And it's always staggering to me when I look at the fact that Soxhlet was developed in 1879, and we're still running that in our labs today, right? If we think about where our world was in 1879 and where we are now, and the fact that we're running a methodology that was run then today, it is like kind of mind blowing. But we are. So it says a lot to that method. It says a lot to how, that method gave us what we needed. And amongst time, we developed some other methods for fat testing, the Babcock test, the Gerber test, the Mojonnier test. And then, as normal with history, we started getting some more rapid methods. So you had an FTIR method, an NIR method, an NMR method. And so I'm going to reference these a little bit in the next slide in a little bit more detail. But if we move over to the next slide, what I really want to talk about is the future of fat testing, right? We're not going to talk about the past anymore. Let's not do a method that is over 150 years old at this point. We're going to talk about the Oracle system, which I hopefully can convince you guys that really does answer all the needs within the industry. So let's move forward. Okay, so we talked about some of the different methodologies, these reference methods and rapid methods. So eventually it falls into these two areas, right? The general fat methods that are out there right now. You've got reference methods. Those are going to be your Soxhlet, your Mojonnier, that type of thing. They're reliable, accurate, accredited, right? This is why we're running them still today. But there's a lot of cons with them too. They're antiquated methods. They use hazardous chemicals. They're difficult to run. They're expensive to run. So that's why people started developing these rapid methods. And so with methods like NIR and FTIR and TD-NMR, they are more rapid. So, and they're easier and they cost less. But the big catch here is they still require calibration with these reference methods. So the reference methods don't go away. You still need them. You maybe just don't have to run them as often, but you still have to calibrate back to it. They can be variable because of this calibration. They can be high maintenance, and they're giving you indirect analysis. You're not directly getting the value of the fat that you can in these reference methods. So with that, there really is a need to bridge these two. We need a reference method that is also rapid. That's the goal at the end of the day. And we're going to achieve that with the Oracle system that I'll be talking about here today. You can go to the next slide. Okay, so before I get into the actual technology, so it's Carl Purcell, MyBoom Gill, pulse time domain, nuclear magnetic resonance. Okay, that's a mouthful. All right, we're going to get into all of that in a moment on the details. I'm going to talk about the benefits first, and really how it does indeed create that bridge. talking about. It is reliable. So it gives us this reliability to reference methods, but it doesn't require any calibrations. It doesn't require the maintenance. It's accurate. And later down the road, obviously, data is important, and Jay's going to cover a lot of that to really bring that point across. It's green. I think for a modern world, that's so important. It does not require these solvents that some of these other methods, and most importantly, is accredited. So it is a reference method. We do have an ISO approval that's listed there for this methodology. So it gives all the benefits of the reference technology as well as that rapid technology without the cons. So let's move on and watch a quick video on how this works. Okay, so in the Oracle is an NMR. So you're going to drop your sample into the magnet. This is going to cause your protons to align up and down. Okay. So when those protons, we're specifically looking, so you see the sample kind of going in there, and I'll cover how to put the sample together in a moment. So basically, magnetic field going to line up and down. We're specifically looking at the protons on the hydrogen molecules of the lipid molecules themselves. So it's a direct technology. Okay. And so those protons on those hydrogen atoms, when we apply a specific radio frequency, it's going to cause those to invert. When that inverts, it's then going to relax. And that relaxation energy, which is kind of visualized by those dots going out right here, that's what we measure. And that is directly related to the fat content in your sample. So again, we're looking at the proton on the hydrogen atoms on the specific lipid molecules themselves. It's a direct technique, requires no calibration, and you get rapid total fat determination. Now that was really fast, so let's dig in a little bit more to that technology on the next slide. Okay, so again, this is CPMG TD-NMR at the end of the day, right? And so that's what's going to allow us to get that direct measurement. So what that's using is a specific pulse frequency that you see pictured here, the 90 degrees followed by the echo of 180 degrees that kind of goes one after another in kind of a train of those echoes. And that is specifically going to, with that specific radio frequency that we have, we can hone in on the lipid molecules. So how do we do that, right? If you're like, okay, well, you talked about these protons. Where are the protons in a sample? Well, the sample is going to have protons in moisture, fat, protein, carbohydrates. So how are we specifically this out? Well, I'll cover this in an exact moment. We are going to remove the moisture from the sample. Okay, so the moisture goes away. We still have proteins and carbohydrates that could interfere. Well, the proteins and carbohydrates, when looking at this specific CPMG TD-NMR, are going to relax at a slower pace than those carbohydrates and those proteins. So we're able to separate them out and specifically look at the fat molecules. But then people are like, but there's a lot of fat molecules. You got your fatty acids, your polysaturated, unsaturated, so forth. Well, within this, we normalize that effect. And so we are getting a total fat value of all the fat specifically in a sample. Okay, so let's move on and talk a little bit about the workflow. Okay, so we mentioned that we are going to remove the moisture. So you see that kind of pictured there, standard oven. So you remove the moisture, you dry your sample, and then you do need to prepare it. You saw that in the video where you had your little tube that you put into the Oracle system. And basically, you dry your sample on the sample pad, just kind of fold it up. We've got a little station that you see there where it helps you prepare that sample together. Goes together very quickly, matter of seconds. And then it does need to be conditioned at a proper temperature. That is important so that we have a conditioning block. To quickly do that, and then you drop in the Oracle in a matter of seconds, you have a total fat value. Now, not pictured here, for those who have a high throughput laboratory, we do have a robot. We'll essentially take it and put, from that conditioner block and drop it into the Oracle itself. So it's basically going to do that for you. So it does have automation as a possibility for those high throughput labs. If we go on to the next slide, we can see another option for moisture. Okay, so in the previous picture, we saw that oven and standard technique, we're just going to do a loss on drying to get our moisture analysis. Well, here, the CEM Smart 6 system is a microwave infrared loss on drying system. And all the benefits we talked about with the Oracle, where it was rapid, easy, and compliant, apply here as well. Okay. The Smart 6 system is 10 times faster than traditional drying methods. It's very flexible. You can use it with any of the products we're talking about. You can use with this smart system, and it pairs directly with that Oracle. So they kind of talk to each other. It's a nice little setup. So you're getting your drying in a matter of minutes and your fat in a matter of seconds. So in a very fast time frame, you can achieve this entire process. Okay, if we move on. Okay. I am going to let Jay cover the data in general, right? Because he's going to take a deeper dive. But I can say all of these wonderful things about the Oracle system and what it does. And if you don't have the data to support that, doesn't really mean much. But so here's just kind of a very high level snapshot of some data, where this is thousands of samples that were studied from CRMs to outsourcing data, variety of different samples from zero to, all the way up to total percent fat. And what you see here is the Oracle percent fat graphed around the reference percent fat. And you see that R squared value of 0.995. It is really accurate, right? And this is what led us to be able to get that ISO approval, right? So it is a reference technology. It is very accurate data. And again, Jay is going to talk more to that and to the reproducibility as well. So we move on to the next slide. And so I said I'd reference this AOC food triangle again because as I started my portion of this talk, I talked about how we want to be able to have a universal method for all of these different types, a very optimized method. And I hope I've shown you how optimized the Oracle is for a both rapid and gets rapid and reference methodology. But Jay's going to dig in deeper here to cover sample types throughout this triangle. So whether it's food, feed, pet food, you can run it. And you don't have to do the calibration. It's universal. So let's move on to the next slide. So just wanted to talk a minute about some of the savings that you get here before I pass it over to Jay. And so here it kind of walks you through a chemical extraction versus a Oracle extraction. And again, no hazardous solvents at all. Very rapid. Doesn't require a lot of bench space. It has less consumable cost, and you're going to get very reproducible data. So, well, yeah, there's a little bit upfront cost for the instrumentation itself. You're very quickly going to get your return on investment there with running this type of methodology. Go to the next slide. So I'd be remiss if I didn't make just a quick moment and talk about the Phoenix Black system. So up till now, we've talked about total fat and moisture, but most of you in your lab probably have a muffle furnace. It's kind of a commodity, right? And you're probably doing ashing for some sort of application. And you may not know that CEM has a next generation muffle furnace. And all the benefits that you've just seen for the Smart and the Oracle system ring true here as well. So it's rapid. It's 90% faster than traditional methods. It brings a lot to the table as far as safety is concerned, and like everything else, compliant. So you can drop this right into having reference methods and compliant data. So we can move forward. All right, so full circle. I hope that I've convinced you that this Oracle system sits as that bridge between reference technology and rapid technology. It is a reference technology. It has ISO approval. It is universal regardless of sample size, no calibration, no maintenance, but it's also a simple workflow. You get rapid results. You don't have to use harmful chemicals, and it's easy to use. So with that, I'm going to pass it over to Jay to really dive deep into the data and prove this concept even further. Thank you.
Thanks a lot, Alicia. Thanks a lot, Michelle. Um, so I'm Jay Alpat. I'm the Chief Science Officer for Chemistry for Certified Group. Now, I would like to shift little the discussion from the science, which Alicia talked about, to the business or the operational aspects of this analysis. Now, as scientists, we are trained to focus on analytical performance, the accuracy, the precision, repeatability. But when we are making decision about a technology investments, we also have to think about the throughput, the labor, the safety, the sustainability, and the return of investment, of course. Now, if you compare Soxhlet with Mojonnier, you'll see that, and the TD-NMR, the difference is striking. Traditional methods typically require anywhere from 2 hours to up to 18 hours, depending on the matrix. Oracle, on the other side, can generate results in approximately 3 to 5 minutes. That is one of the great advantage I see in this. And you'll see a lot of data proving my point. The next one is there's also a sustainability advantage. A traditional solvent extraction method, Soxhlet and Mojonnier, consumes significant quantities of hazardous solvents that require storage, handling, disposal, and regulatory oversight. NMR totally eliminates those solvents completely and improving laboratory safety while supporting corporate initiatives like our organization. Now, Alicia mentioned the initial investment is a little higher. So, as I said, it's a fully validated method. You'll see the data to prove that it is fast, it's labor friendly, no waste generated, and customers are seeking more sustainable green solutions. Then, one of the cons is growing industry adoption. I'll say why people are a little concerned on this technology, and I will show you how we can dispel those myths on why this is this a primary technology or secondary technology? Is it compared to a reference method, etc., etc.? We see a lot of data later. Next slide, please. Now, one main concern we hear from our customers is whether moving this newer technology means sacrificing regulatory acceptance. The answer is a solid no. At Certified Group, our philosophy has always been that scientific innovation should complement, not replace, a validated analytical method. That's exactly the reason we resort to this technology and the method. Now, you can slide a few more points. Yes, please. Next one. Yes. So as you can see, the modern technologies are now available for moisture. For example, in the table you see CM Smart replaces not or complement the moisture analysis. Then CEM Phoenix Black, which Alicia mentioned about ash. Then CEM Oracle for rapid NMR. And modern technologies are now available for all these. And there are other analytes we can do with modern technologies. So what is important in these systems? These are validated against accepted reference methods. You can see that Smart 6 against AUC 95046, CM Phoenix against AUC 94205, CM Oracle AUC 960, AUC 991. In addition to that, you have other added advantages for accuracy, precision, throughput, labor, sustainability, etc. Next slide, please. Now, let us look into this actual data. The slide compares Oracle Smart against reference method for raw chicken as well as for beef blend. The first observation is that remarkable agreement between the modern method and the reference method. You can see the error is 0.06 for raw chicken fat and moisture 0.23. Then beef blend it is 0.01 and moisture 0.05. So for raw chicken, the average results differs only about 1/600th of a percentage, and that's very insignificant. So those differences are essentially whether it's a fat or moisture is insignificant. So what we are not talking about a rapid screening technology. We are talking about a validated analytical method capable of producing results that agree extremely well with established reference procedure. We'll go to one more data on the fat and moisture. Next slide, please. So in the previous slide, what we saw was raw materials. Here, what you see is some finished products. So finished products producers are analytically challenging because they contain complex mixtures of proteins, carbohydrates, fats, and minerals. So by the way, I'll be talking a lot of pet food matrices. We have done a lot of work on food and other matrices, but here our focus is on the pet food. Yet again, there is an excellent agreement in the fat between the reference method and the moisture reference method for canned pet food, as well as canned the finished kibble. So the point here is seeing this level of agreement across different product types provides confidence that I need before we release the results to the customers. Next slide, please. Now, accuracy, that is what you have seen in the previous two slides, is only one part of the story. The other one is the method performance, and the critical part in the method performance is precision. What does that mean? If I do the analysis 10 times, I should expect essentially the same answer every time. That's exactly the precision is. That is what this slide demonstrates. Across a wide range of products, including cheeses, meat, oil, snacks, bakery products, beverages, and dairy, the repeatability is excellent. Low standard deviation, what you see on the last column, 0.13, 0.18, 0.23, etc., indicates that the instrument produces highly consistent results. The more reproducible the result, the greater the confidence me and our team and the lab has before we release the data to the customers. So we see excellent repeatability for the Oracle fat analysis. Let's see what is going on with the repeatability for moisture. Next slide, please. So the moisture, the same story. Whether we are looking at cheese, sausage, pudding, beverage, meats, dairy products, the repeatability remains consistently strong. Most analysis often serves as the first analytical results any manufacturer need for the releasing the products, and operators make processing decisions based on the moisture content. If those results fluctuate between the analysis, that means the poor repeatability, and production decisions become less reliable. Consistent moisture results measurements translate directly into more consistent manufacturing, more consistent results to support our customers. Next slide, please. Now, what you have seen so far is the accuracy of the method, how accurate the results are with what is actually present in the matrix. Then we saw the precision, how repeatable these tests are. So we also do intermediate precision, reproducibility, etc., in a lab. This slide particularly shows how it is comparing with reference materials. But remember, certified reference material provide one of the highest level of confidence in analytical chemistry because the accepted values have been carefully established. So that is how when we develop a validated method, first thing is accuracy, precision, robustness, repeatability, reproducibility, etc. Then the next one is compare with a reference material across a broad spectrum of products, including wheat flour, milk powder, dairy products, processed meats, seafood, infant formula, um, uh, pet food. The SmartSys results are closely matched with the certified values. This tells us that the technology performs well, not only with the routine production samples that we seen in the previous slides, but also against internationally recognized reference material. Now we go to, so you can see the numbers are how close they are and see the standard deviation, very small. That's the one you see in the last column in the slide. Next slide, please. Now again, this one is a kind of educational slide for me and our team. So what you see here is compare directly the traditional with chemistry across multiple food matrices. Overall, you will see excellent agreement between the two methods. But there are some differences, particularly in products such as cheese, milk powder, and liquid. I mean, these differences are actually very educational. So when I do the NMR analysis, then we do the traditional wet chemistry analysis, use some difference. This is the RPD difference for dry milk as well as for milk 1 and 2 and 3. It's pretty high. So that is educational. That's how we work with our team to figure out, okay, what's going on. Is this a systemic bias, or is there anything with the sample preparation? In most of the cases, it's about the sample preparation, which I will show you in one of the uh, uh, later slides. So now, Alicia mentioned that the Soxhlet as well as Mojonnier, they measure the total fat inside. But here in the NMR, we are measuring the NMR measure the total hydrogen associated with fat. So depending on the matrix, sample preparation, extraction efficiency, there may be some systemic differences, but it is also possible to find out to bring these data closer and closer. That means higher accurate numbers by using our sample preparation protocol. So the important point here is the consistency. Oracle method provides reproducible results while eliminating many of the variables associated with the solvent extraction. Next slide, please. Again, this shows this slide expands the previous slides of additional products, including breakfast sandwiches as well as pet food. Again, the agreement between the methods is really high. And for pet food, especially, the average difference is essentially negligible. This is important because, as I mentioned before, pet food represents one of the fastest growing analytical markets. That's the reason we focused pet foods in this presentation. So, as I mentioned before, the manufacturer need rapid releases of the products while maintaining nutritional label accuracy. Technologies, what we're discussing here, Oracle help laboratories to meet both objectives. Next slide, please. All right. Now, Alicia mentioned that these methods, Oracle as well as Smart 6, are validated against the reference method. So these slides, next 3, 4 slides, what I'm going to show you uh, is how these methods compare with the reference method. Whether the application is a meat, as you have seen, the ingredients are oat is a raw material, deboned chicken, rice bran. The workflow remains essentially the same, and the measure of the moisture rapidly with the Smart as well as with Oracle. You see how comparable the numbers. And as you can see, the references are written below. For an example, the oat, the moisture was done using AUC 93401. Then fat was done using AUC 95402. So the point here is whether we are using a reference method or the Oracle or the CEM technology, you see very accurate, precise data. So go to the next slide, please. This case, it is the treats, the chicken treats, pet treats, chicken strip, biscuit, as well as salmon jerky. You can see the average between these two, the reference and the Oracle Smart 6 methods are very close. And you can also see the range in the case of moisture for chicken strip, 0.08. It is, as I mentioned, is negligible. That's what we see across for other matrices, biscuit, salmon jerky. Next slide, please. Again, here we did the raw materials, we did the treats, we did the wet pet foods, chicken, filet mignon, prime rib, and go to the next one. This is dry pet foods, finished pet food that different pet foods we did finished ones, dry matrix. So you can see that how comparable these numbers are with the reference methods. Go to the next slide, please. Now, as I mentioned, see, I would like to finish what I consider one of the most important scientific message in this presentation. And we always, the analysts and the scientists often talk about the instrument performance. In reality, sample preparation frequently contributes more analytical variability than the instrument itself. This study demonstrates exactly that. So on the left side, you see homogenized separately. What does that mean is we have the sample sent to the lab, which did the Mojonnier and Soxhlet, and we do the other lab doing the other location or other lab doing the NMR. That was one case. The other case is where we homogenize in one location and split aliquoted between the labs. So when bacon samples were thoroughly homogenized and then split between analysis, both Soxhlet and Oracle produce excellent precision. However, when separate portions are homogeneous independently, variability increased substantially for both methods. So the lesson is straightforward. Good sample preparation is fundamental regardless of which analytical technology you're going to use. So no instrument can compensate for the non-representative sample. That's the message here. So we, in certified group, we make extreme care to make sure the samples are prepared in a homogeneous way so that the results we are producing are accurate and precise. As analytical scientists, we should always remember that quality of the results begins with the quality of the sample. So there's a garbage in, garbage out. So if you don't put the right sample inside, the sample preparation inside, we are not going to get the right results. So next slide, please. So I will close with a few, one or two key takeaways. First, as you have seen, the modern analytical technologies have matured to a point where they can deliver reference quality data while dramatically improving laboratory productivity. Second, laboratories no longer have to choose or compromise between speed and scientific defensibility. With validated methods, like I've shown in those slides with the data, we can achieve both. Finally, the future of the food analysis isn't about replacing good science. As I said, the good science always complement the traditional wet chemistry methods. It is about using better tools to strengthen high quality, faster data sustainably and at lower overall cost. So it's all about turnaround time, the cost, as well as the sustainability. And with that, we'll end the presentation today. Thank you for joining us, and we'll be more than happy to answer any of the questions. So Michelle can look into the questions being addressed in the chat, then we can answer one by one. Thanks,
Absolutely.
everybody.
Thanks, Dr. J and Dr. Alicia. That was very informative. We do have a few questions in the Q&A section, and we also have a few questions that were sent in prior to this presentation. So I'll start with the Q&A questions. Just keep in mind if we don't get to your question that we will respond to you and get you a personalized answer. The first question is the NMR time, 3 to 5 minutes. Does this include the drying step?
Hi, I'll take that question. So the 3 to 5 minutes does include the drying step if you're using the Smart 6. If you were to use an oven or dry, in via reference method, then that step would take longer. But if you're using the Smart 6, that 3 to 5 minute total time would be for your analysis, for your moisture analysis and your fat analysis.
Thank you. I have a few questions surrounding the cost of the instrument, which I'm sure is something you would address on a personal basis. But could you walk us through maybe the first step in acquiring this equipment?
Absolutely. So if you see on the screen my email address, eileen.sokol@cem.com, if you send an email to me, I will make sure that your information is passed along to the representative that would help you get pricing information.
Okay. Let's see here. I have a question internally about bringing this, technology into our laboratory. And so the question surrounds what the projected lead time to get up and running would be.
Yes, so for a moisture and fat analyzer, we have about a 6-week lead time. Since we do not require any calibration or methods for the fat analysis side, typically as soon as we have that set up, your instrument would be able to run immediately. So it's about a 2-day install process. So from the moment you get it and we install it, it would be ready to run.
Yeah, so we in our lab, maybe some of our team members are here. They can attest that it is almost a day. So they came in the morning and does it, and these methods come in flash drives. We can insert it. We can run. The only thing what we do in the lab is we make sure uh, any customer samples before we do it. We do a comparison study between in our labs itself. The comparison between Mojonnier, Soxhlet, the NMR technique to find out what is the RPD difference, as I mentioned. That is one thing I will always look for. Bring that RPD closer and closer so to make sure that numbers are accurate. So before we started working with any customer sample, because most of the samples, most of the customers have been using Soxhlet and Mojonnier for a long time. So that conversion required data to prove that it works well for their particular matrix.
Okay.
Thank you, Jay.
Sure.
We have a few questions surrounding maintenance of the instrument. Somebody has asked, they said that they purchased Oracle last year and want to know when they should start the preventative maintenance program. And if you could elaborate on what you do when you have to do maintenance, do you go out to their site?
Sure. So typically, one of our service engineers would lead the preventative maintenance program with the instrument. Typically, after we do the first visit after a year after install. So once that's typically when the warranty would run up. So we would come out and we would clean the instrument and then just ensure that everything was running correctly. We would look at some of the software, look at some of the historical data within the system as far as how it's running, and we would use that to evaluate any issues that the system might have on the back end. But typically, it's about a year after install that we would start that preventative maintenance program.
Okay. I do have some questions surrounding matrices. Are there any matrices or additives that can skew results for the NMR method?
Typically, since it is a primary method and we're looking at hydrogen, again, the proton on the hydrogen of lipid molecules, we've gotten pretty honed in on where that fat signal is and how it's releasing that energy. So typically, we don't see a lot of additives or anything like that skewing results.
Okay.
So this is for my curiosity. Maybe Eileen, you may be able to answer if some of those matrices have some paramagnetic ions,
Mhm.
metal ions. Will that skew the results, or if we need to modify the pulse sequence or whatever? Is that something have you seen?
We haven't. So, if there's something that might be magnetic, that would be in the magnet, like a significant amount of heavy metals or something, maybe. But we haven't seen any issues with anything like that in the past.
Okay. I've got a question about an underestimation in fat content for dry milk samples. Have you seen that occur?
So that is one of the slide I had. So what my observation at that one was the sample preparation. So one of the thing what we found between the traditional analysis with if you do on the same day, almost similar time, they are very comparable. But if you take it off a few days, few months, etc., that is because of the chancer for either the powder absorbing the moisture or losing the moisture during the storage. That was the reason why we found in our lab causing that higher RPD for us. So what I suggest our team is whenever you are comparing Soxhlet, Mojonnier, and NMR, let us do it as close as possible because we don't want to add additional variation that can lead into changes in the moisture content because that is very critical in calculating the fat analysis.
Dr. J, how long does it take to get the result for solids and fats from sweetened condensed milk?
This will be the same, as said, it is the same sequence, same time,
Okay.
3 to 5 minutes.
Great. I do have some questions about the actual procedure. How long does the sample need to be placed in the heating block for conditioning? Is this a necessary step in between the drying and fat analysis if the drying is being carried out using the Smart 6?
Yes, so if the drying is being carried out by the Smart 6, you do not need to condition it. So whenever Smart 6 methods are made, we will use the Smart 6 to either cool the sample or keep the sample at a desired temperature so that from the time the sample exits the Smart 6 is prepared to be placed into the Oracle, that it is at the appropriate temperature. So also on top of the Oracle is a heater. We call it the Quick Prep. So when using the Smart 6 in the Oracle, if needed, CEM would customize a method that might use that quick prep to heat the sample as well. So if you're using the Smart 6, you do not need to condition the sample in a heater block. If you're using the like a drying oven, then you do have to condition the sample in a heater block, and that's so that it will enter the magnet at the appropriate temperature. You want a consistent and homogeneous environment. So you want the sample temperature to be as close to, if not the same as, the magnet temperature.
Okay. Is there any method that can be used to periodically verify the calibration?
So I can answer that as well. Jay, you might want to chime in as well.
Sure.
But we typically suggest that customers would use certified reference material if they want to check their system.
Right. So that is what we do. So Alicia showed that matrix AOC for triangle. So we normally create or may keep in our lab some of the certified materials from different regions so that we can confirm the performance of the machine. And I saw another question. Maybe I can answer that right now. Uh, what about the standard deviation, expected standard deviation for moisture and fat? It all depends on the quantity. If it is a lower quantity, we expect a higher standard deviation. Then if it's a higher quantity, we expect a lower standard deviation. So normally my experience is anywhere between 2 to 5%. In the extremely low, I've seen up to 15%. Otherwise, it is 2 to 5% standard deviation we have seen with the NMR.
Okay. How do we dispose of the dry sample pad? Can this be thrown away?
Yes.
Okay, simple questions. What about developing the method for product type? Can you adjust the fat up and down? How would that be done to kind of develop the method for product type?
Sure. So the Oracle uses a universal method, so there is no adjustment needed on the Oracle side because it is a direct measurement. So we don't require calibration or method maintenance or anything like that. The only development that we require is on the Smart 6 side, if that's what you're using. So that's where we would adjust, to make sure that you have the optimal sample temperature when the system or when the product is entering into the Oracle. So as far as the Oracle side of things, there is no method development. There is no adjustment that is made.
Okay. I think you might have answered this in a roundabout way, but if you could talk a little bit more about the significance of the cooling step when using Smart 6 and explain the different settings for the Oracle when connected to the Smart 6.
Sure. So as far as the cooling step, when the Smart 6 is finished running, depending on what temperature is used to dry that sample, the cooling would just be so that the sample is at a temperature that you would want to handle it at. And then once that sample is taken out of the Smart 6, it's prepared and then immediately placed into the Oracle. So really that cooling step is really just to optimize the temperature before it enters the magnet. As far as different settings between the Smart 6 and the Oracle, I might have to reach out to whoever asked that and kind of get a little bit of clarification on what kind of settings they're looking for. Just because the Smart 6 will give you the moisture, the Oracle will give you the fat. So I might have to get some clarification on that question, what exactly they're looking for.
Okay. And Dr. Alicia, I have one more question for you and then one for Dr. J as well. When putting the sample on the pad in the Smart 6, this person was taught to put the dots in a swirl and do not touch. Is this true? They have also seen people just put it all in the center. What is your take on that?
Sure. So it sounds like, so with our previous version, we had a few different techniques used to place the sample on the pad. With the Smart 6, typically we suggest that you puddle the sample into the middle of the pad. That's because of the IR sensor and how it looks at the pad, so that helps control temperature. So we always suggest with the Smart 6 that you puddle the sample into the middle of the pad when using.
Okay. Is this instrument going to give just a total fat result, or can saturated and unsaturated be differentiated?
Yeah, so I can answer that question. We also had a question before somebody registered. So basically, they're asking, will be able to see the fat as a profile? No. So we can do only the total fat. Anything beyond that, this the specific question was on saturated fatty acid, unsaturated fatty acid, CLA, etc. That has to be done through GC analysis. So
Okay.
this is only total fat.
Thank you. How will results differ from historical data if someone makes a switch to this method? How would you handle that?
That's a really good question. It all depends on historical data, how it is being done. If it is Mojonnier, it was done according to the reference method. I do not see a big difference whether it is done in 5 years, 10 years, 15 years, or I mean, Mojonnier and Soxhlet, it has been there for a long time. So the AOC reference methods put specifics on how long he has to be heated, how long to be extracted, how long to be, etc. So if they are according to AOC conditions, and I will not see much difference between what we see. When I say will not see, is the RP difference will be maybe 5% up to 5 to 10%. That's what I would see with the traditional data, historical data, and data done at this point with NMR.
Okay.
Hey, Michelle, I just wanted to pipe in real quick. I apologize, I've been very quiet during this, but Eileen is here and she's the product manager and she knows all the specifics. She's got, she's in the lab and running these systems with her team every day. So kind of letting her handle the technical questions here. I am your contact though, on the road at shows and so forth. So we just referenced AOEC. So like AOEC Annual is a great example. That's where you can contact with me. So I certainly can, I'm a great reference, but for the technical questions, letting Eileen handle it here today. Just wanted to make that comment.
Sounds good. Thank you for clarifying that. I have some other technical questions about the instrumentation, but in an interest of time, maybe I could cover a few more general questions to give both of you some time to speak to this. I would like to hear from Dr. Alicia and then also from Dr. J about the same question. What differentiates you from other competitors?
Alicia, you want to start?
Eileen, I'm gonna let you handle this one.
Okay.
Mhm.
Sure. So, the biggest differentiator as far as CEM goes is the technology that we're using. So, you heard mention of NIR in the presentation. We're using NMR and we're using specifically CPMG pulse sequence for our Oracle system. That allows us to have a primary method or a direct method for analysis. So the biggest differentiator is, as far as the technology goes, would be that we're doing direct analysis. I think one of the other things that really sets CEM apart is our service and our accessibility. So we're always here to help, and we have several service people located around the world, not just in North America. And so I think those are some of the biggest differentiators as far as CEM goes.
Yeah. I can tell you, as far as the certified group is concerned, I briefly mentioned our philosophy is to innovate. So we always find scientific innovation that should complement our existing method. That's exactly what we did with this. So automation, scientific innovation, bringing in AI, make shorter turnaround time, as well as accurate, precise results. That's number one. Number two, so I have the people who generated this data for us. Zach is here today, Adriana and Lydia from our San Antonio lab. Our Springdale lab is the one which first brought in, which Michelle Kelly is a part of that initiative. So those people are the one worked and created this data, optimized the method for us. That's number one. Unlike some of the other companies, these people are available to talk with the customers. If you have a question, you can call the phone. Zach will be on the line. Adri will be there. Lydia will be there. That is one thing I find it a differentiating factor for us. Then the last one, as I mentioned before, we just do not get a sample and deliver the results. We study the material what they're sending us. We optimize the method for them. So in some cases, we need to spend days together to compare our Soxhlet Mojonnier data with NMR data to make sure they are closer and closer and accurate before we deliver the product to our customers. So that is the kind of few points I consider that differentiate us from some of the people in the similar area.
Thank you for that, both Dr. Alicia and Dr. J. We appreciate your comments and your answering these questions candidly. That's really all the time we have left for answering questions. I would like to thank you all for attending our webinar today, and don't forget to download the white paper that's located in the chat. We hope this collaborative effort has brought you the insight you need to apply this to the important work you do. Have a great afternoon, everyone.
Thanks, everybody. Thanks for
Yeah,
joining us
thank
today.
you.
Bye-bye.
Thank you.
Bye-bye.